Hello, welcome to another session. We are going to continue the topic approximation and errors, and we are going to look at propagation of errors, and in this case, we are going to concentrate in error in multiplication. We are going to do three examples to be able to see how it can be able to be tested on this area. And we are going to start with an example one. It's a KCSE question that was done in 2015, paper 2, question 1. The question says that the length and the width of a rectangular piece of paper were measured 60 centimeters and 12 centimeters respectively. Determine the relative error in calculation of its area. So we want to get the relative error when we get the area of this particular piece of paper that is measuring 60 by 12 centimeters. So the first case here, for us to get the relative error, we can first use the various ways of getting that, but we're going to first get the relative error. And when it comes to the multiplication, the absolute error, we are going to find first is to get our values. We have 60 as the length, and we have 12 as the width. Then we find where these values rise, and of course 60, of course the least measure is 1, meaning it's going to be half of 1 is 0.5. So we add or subtract 0.5, so you can get a maximum of 60.5, and the lower limit is 59.5. Then for the 12, it's the same, plus or minus 0.5, you get 12.5 or 11.5. So that is our limit for the length and the width. Then we want to get the, we can start with the actual measure, or the actual area. It will be the length times width, and in our case we have 60 times 12, and this one we are going to get as 720. Then we have the maximum value, maximum area. Of course, this is going to be given by the upper limit multiplied by the upper limit, that is 60.5 times 12.5, and when we multiply the two, we're going to get the value as 756.25. Then you also need to get the minimum area, and this is going to be the lower limit multiplied by the lower limit, that is 59.5 times 11.5, and when you multiply the two, we are going to get 684.25. So when we have that, for us to get the absolute error, we are going to have absolute error is given by maximum minus the actual. Into bracket we add actual minus minimum. Then we divide this one by 2, and this is going to be having our maximum here is 756.25 minus 720. We add the actual, which is 720, minus the minimum 684.25. This one is divided by 2, and this one we are going to get as that 6.25. That is 756.25 minus 720, and then 720 minus 684 is 35.75. this one we divide by 2, and you're going to get the value as 36. So that is the absolute error. Alternatively, for the absolute error, you can also get it as the half of maximum subtracts the minimum. That is a half of the maximum. We have 756.25 minus 684.25, and when we subtract the two, the 756.25 minus 684.25, that one is going to be 72, and half of that one is going to be 36. So that's how we get the absolute error using that method. Then for the relative error, that is our question. We know that relative error is given by absolute error. We divide by the actual measure. So the relative error, in our case, we have as the absolute error as 36. We divide by the actual area, which is 720. And this one is going to give us 0.05. So that is the relative error of that, getting the area of that piece of paper. Alternatively, for the relative error, we can get to the relative error as we have the absolute error of each measure. For the 60 is 0.5. You divide by the value, that is 60. We add the relative error of the second measure, that is 0.5, divided by 12. Just like that, that's an alternative way of getting relative error. And when we add the 2, they should give us the 0.05. So generally, for the relative error of when you multiply two numbers, you can get as relative error of each individual figure that we are having. We add the other relative error of the other measure, and then we add the 2 to get the relative error of the measure of the area that or the two numbers that are multiplying. So let's look at example 2. This is also a question from the KCSE 2016, question 2, and the question reads: by collecting each number to one significant figures, approximate the value of 788 multiplied by 0.006. Hence, calculate the percentage error in calculation of its area. So in this case, we can start by getting the actual value. The actual value here will be now the 788 multiplied by 0.006 before we do the approximation. And this is going to be 788 times 0.006 is 4.728. So that is the actual value. Then the approximated value, we are going to get now the 788 related into one significant figure, and this case is going to be 800 times the 0.006 in one significant figure. So we want to be the same as there, 0.06, and then when you multiply these two, we are going to have as 4.8. Then our question is to get the percentage error. In the first case, it's good now the absolute error or the error in that's good to occur here. So you get the actual value 4.728. You subtract the approximated value 4.8, and of course you're going to take the absolute value of the same, and this is going to give us as 0.072. So that is the error, the absolute error in that case. But we want to get the percentage error. So the percentage error, you're going to first get the relative error, which is going to be the absolute error 0.072. We divide by the actual value of 4.728. Then the percentage error will be the 0.272 relative error times 100%. And then multiply that, you're going to have as 1.522 and 1.5228%. So that is the percentage error, 1.5228%. So let's look at our last example, and the question reads: the measure of a radius and the height of the cylinder are given as 8 centimeters and 9.5 centimeters respectively. Calculate the percentage error in the value, in the volume of the cylinder. So in this case, we want to get the percentage error that you're going to have in the volume of the cylinder. So first case here, we are going to give the limits of our measurement, the radius and the height. So the radius is 8 centimeters, and then the height is 9.5 centimeters. So the absolute value for 8, of course, the relative absolute error for 8, this is going to be the least measure here is 1. So half of 1 is 0.5, meaning that it is either plus or minus 0.5, meaning you can have 8.5 or 7.5. For the 9.5, the least measure here is 0.1, then the absolute error in that measure will be half of that, and you're going to get us 0.05, meaning now our 9.5, the upper limit should be 9.55, and then the lower limit 9.45. Then we know that the volume of a cylinder is given by pi r squared h. The pi is constant, but we have the pi times radius times height. So I'm going to multiply radius to radius times radius and times height. And in this case, for us to get the relative error, we can use the relative error. We can use the relative error of each measure. For the radius, relative error is going to be 0.5 divided by 8. Then we add the second radius there, the absolute error is 0.5 over 8 to get its relative error, and then the relative error in 9.5 is going to be, we add as 0.05 over 9.5. So you can get the relative error in that way, instead of going through the route of getting the absolute error and relative error. Then when we add the 3 values, we are going to get as 0.13, 0.13026 as a relative error. And then to get to the percentage error, we have the relative error times 100% percent, and that is going to be 0.13026 times 100 percent. We just go 2 steps forward, 1, 2, get 13.026 percent.